Hi everyone. Welcome to our video on the product rules. So in this section we will cover both the product and quotient rules, but in this video alone, just the product rule. So the product rule is used to find the derivatives when we have a product, so some expression times some expression, and it's given as this. So we use u and v often for our function letters because they don't get used very often in other things. But what it's saying here is the derivative of u times v is u prime times v plus u times v prime. So often I'll abbreviate it so the same way that I just said it. So the derivative, I'm going to say of u times v. So of x is nice, but this is abbreviation. I often just think, all right, so if I have a product, to find the derivative of it, I just rewrite them just like that. So I see it and I just rewrite it twice with a plus in between. And then I just think that the prime should alternate. So u prime on the first one and then v prime on the second one. Okay, and this is with u and v. They could use whatever letters they want to use. So if they use like f times g, I would still think, hey, just copy those two letters with a plus sign in between and then alternate the derivative symbol. Okay, and as long as you alternate it, it works. So for instance, one other way, so equals, again, you could just write it twice just like that, and then just make sure the prime alternates. So you could do the v prime and then make sure the first one, if the first one is v prime, then the second one is u prime. Okay, so again, as long as it alternates, it's good, and it doesn't really matter what letters you use. It's entirely up to you. All right, so let's see how this works. And the product rule can often be avoided if we just FOIL. So let's make a note of that. Product rule can sometimes be avoided if we just FOIL something out, or if we multiply first. Okay, so sometimes we don't even need the product rule, but it is now one of our tools that we can use. Sometimes we have to use it, so we'll see eventually that there's times where we have to use it. In this scenario, though, this very first one, we are going to show it in two different ways. All right, so in this example, it says find the derivative using the product rule, and then we'll also check by multiplying the product and then taking the derivative. Okay, so on this one, product rule will go first. Okay, so what we would do on our product rule is we would state that this is our u, this whole thing right here, and then this is our v right there. And so all I'm going to do on this problem is let's instantly just write our derivative notation. So the derivative of y with respect to x would be dy dx equals, so the derivative of a product, I'm just using my rule for now, is uv plus uv. And then again, I just make sure to alternate. And careful with the way you write v. Sometimes there we go. Sometimes it looks like u. Okay, so I have u prime v plus uv prime. And then now I'm just going to start to substitute these in. So I have dy dx equals, let's go ahead and use some color. So I'm going to do my u, I'm going to keep it in blue. Okay, so u I can see right here, and then, well, I can find the derivative of u without much effort. The derivative of 3x plus 4, the derivative of 3x would be 3. The derivative of 4, since it's a constant, would be 0. So there's that, done. And then let me do the v portion in red. So there's my v. So, and then I have v here, which is just 2x minus 1. So I just am copying that same thing in the second parentheses. And then we have our plus sign. And then we have just u. Okay, so I've got just u. And even these you can put in parentheses if needed. Okay, so I'm going to do that too on this problem. There we go. Just to really color code it. Okay, anyway, so the u was what I labeled at the beginning, just the 3x plus 4 in parentheses, just like that. And then v prime, well, I can take this derivative with no problem. It looks like it's just 2. So the derivative of 2x minus 1 is 2. And then now, so we did the derivative, and then like most derivative problems, we just need to simplify afterwards. So dy dx, this 3 would distribute. So we'd have 6x minus 3. And then this 2 would distribute. So I'm just distributing. And it is positive in front, so it'll say it's plus 6x plus 8. Like that. And then now we have the answer. Really, we just can simplify. We see 6x plus 6x is 12x. So our dy dx is 6x plus 6x is 12x. And then minus 3 and positive 8 would be plus 5. There it is. Okay, so that's how we can use the product rule. Now, for number 2, let's do the checking. So number 2, let's just write out our function again. So 3x plus 4 times 2x minus 1. Okay, so on this scenario, we're just going to FOIL this out first. So I still have y equals 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. 4 times 2x is positive 8x. 4 times negative 1 is negative 4. And then we can combine the middle term. So we have y equals 6x squared plus 5x minus 4. And then now we can do this derivative. So we multiplied first, and then now doing the derivative, we have dy dx is 2 times 6 is 12, and then x to the first power, plus the derivative of the second term is just 5. The derivative of the constant is 0. So we can see it works the same. We get the same answer. Okay, so that's what I mean. So the product can sometimes be avoided. Like on this, I would say this number 2 method is easier. Number 1, though, wasn't much worse. Okay, so neither of them are terrible. Okay, but you have your options in some problems to go whichever way you want. All right, so let's do a few more. On these, I am just going to, we're going to just use the product rule for practice, because again, eventually we do need to know it, so we'll need it in some functions eventually. But for these you could FOIL out and find the derivative using our methods from before, like in number 2, on this number 2 here where I'm swirling around. All right, but for practice, let's make our product rule. So either way, on number 1, we would want to rewrite it. So it's f of x equals 3x minus 7 times 3x minus 7. So when you see that square, if we're using the product rule or if we're using the other method, we would still need to rewrite it. All right, and then with this is my u. I'm going to show this one with my colors still. So this is my u, and this is my v. So my u, and some students like to write it out like this. Here's my 3x minus 7. And then my v is also 3x minus 7 in this case. So they happen to be the same. And then some students like to go ahead and just say, oh, u prime is 3x minus 7's derivative is just 3. And then while v prime is the same thing. V prime is also just 3. So that way we could see it all. On the previous one, I just jumped into it. But this one, I'm just writing out to the side first. Okay, regardless, I would say still write your equation out. So your f prime of x, let me go ahead and put that in blue. F prime of x. Let me fix that. So f prime of x is, so this is u and that's v. So we'd have uv plus uv. And again, so this is my just quick setup. And again, I'd say, hey, just make sure to alternate the u and the v primes. And then now I could start plugging all those in. So we have f prime of x is u prime, which is, I can see over there is 3. V is 3x minus 7, so I have it all listed out with my colors. And then I have plus u, which is also 3x minus 7. And then v prime, I can still see is 3, just like that. And then very similar to before, we would take the 3's and distribute. So this 3 distributes, this 3 also distributes. So we'd have f prime of x is 9x minus 21, and then plus 9x minus 21. And so it looks like for our final answer, our f prime of x, 9x plus 9x is 18x. Negative 21 minus 21 is minus 42. There we go, done. Okay, so that's using the product rule. This one was a special case where the u and the v happen to be the same, but it worked out. You could still, again, FOIL it to double check. It would work the same. We would get this answer. Okay, so you could always double check. All right, one more. This g of t is set up with harder kind of powers, at least. So this is still what I'm going to call u, and this is what I'm going to call v. All right, and let's set that up. I'm going to do, so on that one I put it way to the side. Here I'm going to just kind of put it underneath. So the u, and let me label it even above, is t to the negative 1 plus 4. And then let's go ahead and just find that u prime then is, all right, using the power rule, negative t to the negative 2. And then that's it. The plus 4's derivative is 0, so this is set up. And then with our red portion, so that's the v. So I've got v is equal to, it's probably easier to go ahead and change the square root now into the half power, and then minus t to the 1.3. So here we've got fractions, and you could even change the 1/2 into 0.5. Okay, but now that it's set up like this, let me go ahead and find its derivative. Okay, so the 1/2 t to the negative 1/2 is the first derivative, minus 1.3 t minus 1 from that power would be 0.3. Okay, so there's my u, v, and u prime, v prime all ready to go. And so then I can set up my g of t. Now I'm going to put that over here where I'm saying it is u times v to abbreviate. And then now I usually use my blue to show I'm starting the derivative. And so I see these two letters and I just, all right, I know the product has a product rule where I just write it as uv plus uv, and then I just make sure to put the primes. So u prime v plus uv prime. And then I can start to plug everything in. So our g prime of t is u prime, which is the negative t to the negative 2, and then v, which is t to the 1/2 minus t to the 1.3. And then we have our plus u, which is the t to the negative 1 plus 4. And then we have our v prime, which is the 1/2 t to the negative 1/2 minus 1.3 t to the 0.3. So be careful with the product rule. So on this problem, I very nearly ran out of room. So sometimes it really goes long. So just give yourself plenty of space on these scenarios. And if you do run out of room, make the adjustment and just, I would say, start over and give yourself lots of space. So don't just try to cram things in. That can often lead to mistakes. Okay, anyway, so this is the derivative. It is ready. And then now let me move this over a bit so that way I know for sure I have enough room. And what they would do, well, I've got integers on this, and then I have decimals and fractions. So I'm going to change the half power. I'm going to change that half power into a decimal because I think if they have decimals going on in parts of it, I'm going to just make it easier for myself to change them all into types of decimals. Okay, so that's all I'm doing in this step. So I still have the negative t to the negative 2. And then t to the 0.5 is how I'm going to write that, because 1 divided by 2 is 0.5, minus t to the 1.3, and then plus t to the negative 1 plus 4. And then even this 1/2, so I'm going to go all decimals. That 1/2 too, I'm going to change to 0.5, and then t to the negative 0.5 minus 1.3 t to the 0.3. Okay, and sometimes with the product rule, they might just want you to set it up like this just to show that you know the whole rule, and then we are done. However, I am going to continue simplifying. I'm going to take this and distribute it. Okay, so I have g prime of t is, all right, so I have negative t and a positive t, so that would stay negative t. Negative 2 and the 0.5 would add, so that would be negative 1.5. And then the negative t and the negative t is positive t. Again, these powers, the negative 2 and the 1.3 would add, so I'd have negative 0.7. And then this portion needs foiling. Okay, so this is a little worse. Okay, so to FOIL this out, the t to the negative 1 would multiply each of those. So we'd have plus, that plus is there, so t to the negative 1 times the first one would give us the 0.5 t, the negative and the negative would add to give us negative 1.5. And then the t to the negative 1 times this negative 1.3, t to the 0.3 would be minus 1.3. T to the negative 1 and the t to the 0.3 again would add, and that would give us a negative 0.7. And then still continuing to FOIL, this positive 4 would multiply each of those as well. Positive 4 times 0.5 would be positive 2. And then t to the negative 0.5. Positive 4 times negative 1.3 would be negative. And then this would become 5.2. So 4 times 1.3 is 5.2. And then the t to the 0.3 is still attached. Okay, so this one shows, so if the powers are nastier, then we got a nastier expression. But I think we're almost there. It looks like I can collect our final like terms. All right, so let's see. So let's be careful. I'm going to use my highlighter. It looks like I have a negative 1.5 power that lets me combine these, and then the other powers are not negative 1.5. Okay, so this is good. So I really have negative 1 here. Negative 1 plus 0.5 would be negative 0.5, and then the t to the negative 1.5 is the power still. And let me clean that. That looks bad. Let's change that. Negative 1.5 there. Okay, and then it also looks like I have one other common term, like terms, the negative 0.7 power. Those are common. And again, I have a positive 1 here. Minus 1.3 would give us a negative 0.3. T to the negative 0.7. And then after that, these don't have like terms, so just make sure to include them still. So plus 2 t to the negative 0.5 minus 5.2 t to the 0.3. All right, there we go. And the order of these, you can switch the order around, but there should be those 4 terms. Okay, so there's the product rule. So they're usually not too bad. This number 2 is kind of as nasty as it gets. All right, so either way, I would say get the colors involved. I think they're helpful. Don't be too cool to use colors. All right, colors help. All right, so but that's it. If you do have questions, please let me know. Otherwise, I'll see you next time, and thank you for watching.